All right, here we go. The last lesson in Unit 9. This one is kind of similar to last lesson, but instead of law of sine, we are going to talk about the law of cosine. So again, it's kind of similar. If we're trying to find like side A, notice again that part of our equation uses B and C, but then it uses cosine of A. If we're trying to find side B, well, then you say, okay, well, we're going to use A and C, and then we're going to talk about cosine B. And again, vice versa, if we're looking for C, then we're going to use A and B, and then talk about use cosine C. So let's jump into an example where we do this. So if we draw the triangle, looks something like this. Let's call this A, B, C. C equals 14. This angle is 34 degrees. A equals 11. And then this is B. So if I'm trying to find B, I'm going to say, all right, B squared equals A squared plus C squared minus 2AC cosine of B. So filling in what I know, B squared equals 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34. When you go through and simplify that, you get B squared is approximately 61.7, but we don't want B squared. We want this just B. So if we take the square root of that, we get approximately 7.85. Once we have this, information, we can then use what we've previously learned using the law of sines to fill in for A, B, and to solve for the angle A. Because again, we still don't know. We found that this is about 7.85, but we don't know what angle A or angle C is. So if I use my law of sines, which I learned last lesson, I'll say, okay, sine A over A equals sine B over B. Plugging in what I know. I want to find A. Cross multiply. You end up getting approximately 0.7836. I'd say 4 decimals is good, but remember, that's not our final answer. We need to find the inverse because that's how we get our degrees. 0.7836, which again is approximately, should use the squiggly, 51.6 degrees, which if I know that angle B is 34 and angle A is 51.6, I can take 180 and subtract what I know to find that angle C is about 94.4. So C is 94.4 degrees. So you may have to use the law of sines and cosines to fill in some of this missing information. What happened here? Get rid of this. Okay. So I guess let's just highlight what we learned. Okay. These are the 3 things that we needed to find. Another example, slightly different triangle. Something like this. Let's call A equals 12, B equals 27, C equals 20. So this is a side triangle. This last one was a side angle side. This one is a side triangle. Find the angle opposite the longest side AC. Use a law of cosines to solve for B. So again, B squared equals A squared plus C squared minus 2AC cosine of B. All right, so plugging in what we know, 27 squared, 12 squared plus 20 squared minus 2 times 12 times 20 cosine B. And then to get B all by itself, I have to simplify this. And basically what I have to do is subtract minus 12 squared minus 20 squared. So I would get 27 squared minus 12 squared minus 20 squared equals negative 2 times 12 times 20 times cosine B. And then I'm going to divide negative 2 times 12 times 20. I'm saving this. You could simplify it. I'm just going to do it all in one step. So I'm keeping it unmultiplied. So this cancels out. So cosine of B is going to equal negative 0.3854. And then when we find the inverse of negative 0.3854, we get approximately 102.7 degrees, which when we look at this angle, it does look rather big. So this 112.7 degrees does make sense. As far as how do we figure out the rest of ours, we either need to figure out A or we need to figure out C. So I'm just going to go ahead and find A. I'm going to use my law of sines to figure out, now that I know what B is, I can use that. So plugging in what I know, sine A over 12 equals sine 112.7 over 27. Again, law of sines was last unit or last lesson. Cross multiply, get sine A by itself. It should equal 12 times sine 112.7 divided by 27, which equals about 0.4100. And when I use my calculator to find the inverse of sine, I get approximately 24.2 degrees. Again, triangles always have 180. So if I subtract the two that I know, I should get approximately, for angle C, 43.1 degrees. We also have Heron's formula, which is a way to calculate area of a triangle. So we've got this area formula for our triangle. And again, I guess the important parts are, how do you calculate S? What's S? S equals 1/2 A plus B plus C. The variable S is called the semi-perimeter or half perimeter of the triangle. So if we try to take an example, let's say it's urban planning. The intersection of 3 streets form a piece of land called a traffic triangle. So actually, I'm just going to take a picture. It'll be easier to show you. So the intersection of these 3 streets form a triangle like this. You may if you are driving around, you may see an intersection that looks something like this. So the first job is to find S. So again, S equals 1/2 A plus B plus C. So as I'm plugging in what I know, 170 plus 240 plus 350 multiplied by 1/2. This is going to give me, here, let's just put it down here, equals 380. So S is 380. Once I know what S is, the rest of my formula becomes pretty easy. So the area is going to equal S, which is 380, times S minus A, so 380 minus 170, multiplied by S minus B, 380 minus 240, and again, this is the formula right here that we're using, multiplied by S minus C, which is 350. So 380 minus 350. And so as I go through, if I simplify my parentheses and I multiply everything out, and then I take my square root, my area is going to be approximately 18,300. So that's going to be square yards. All right, there you have it. That's Heron's area formula. So we're kind of used to the 1/2 base times height, but if you don't know the height, you may need to use Heron's area formula.